Hello everyone, welcome to another live coding. Today we're going to go looking for snow, and since it's coming close to winter. And besides just looking for snow, which we'll be using a neat little deep learning model for, we'll also be looking at one new feature in PerceptiLabs, which makes it easier to load data. And I'll also show an interesting case where you don't want to normalize images, which I just happened upon. So yeah, we'll see both of that. But yeah, let's get into it. And hope everyone had a good week so far. So starting from the beginning, we'll take a look at the dataset we're going to use. Which we have here. It's a weather image recognition dataset. You can find it on Kaggle. I don't think the link is in the description quite yet, but it should be when the video gets released, if nothing else. And just ask me in the chat if you want to have it, and I'll post it there early. But in this dataset, we have a bunch of different categories of weathers. One of them being snow. So the idea here is that we build a classification model which looks through these images and it finds out what's what. And we have everything from well, snow of course, to sandstorms, to rain, to lightning, and it's a pretty neat little data set. And besides just looking for snow, you could probably use this to automatically detect how the weather is where your cameras are set up if you're running something remote. Maybe that could be good information to know about. But let's get into the actual modeling. I've already downloaded this dataset, and we're ready to load it into PerceptiLabs and start building our model around it. And here's where you see the first new feature. Not the first new feature. Here's where you first see the new feature. You're now able to select what you want to do. So instead of just loading a CSV file, you can select if you want to load a image or if you want to do an image classification problem, if you want to segment images, or if you want to do multimodal, where multimodal is the normal CSV option you had before. Here you just load in your CSV file. But in our case, we're going to do image classification. So we pick that. We can of course use public datasets as normal, but I'll go to local. And here's the difference. I no longer have to select a CSV file. Instead, I just choose a folder with a bunch of folders inside it, where each folder is a class. So I'm gonna go ahead and do that. And I don't think you can see my file explorer, but I'll just select it in background. Like so, and then we press next. And what happens is that it will look through your dataset and it will create a CSV for you in your data root folder. And we'll use that instead. So you still have the CSV, which you can use as a ground truth, and you can look through it if you want. But it's much easier to get started since you don't need to create a CSV from scratch. Now in this, it's also going to be automatically recommended everything in the data wizard, so you don't need to worry about setting that up. But in here, and this is, I'm running this on the development branch, and this is a little bit of a bug. This should only be in segmentation, but this is what caused a cool little insight. So in this case, we're actually normalizing. And it turns out that when normalizing in this dataset, it causes way, way worse performance. To the point where it can't tell anything apart. And I figure we would run that version of the dataset first, and then we will do another version where we don't normalize it, and we can see how huge the difference is. We also resize to 124 by 224 by 224. I'll lower it to 100 by 100, make things go a little bit faster. And then we can create it. There we go. There we have a model. So in this model, I'm going to use MobileNet, which you can find under here, public. I'll probably... You can try out a few different ones. Before this, I tried out MobileNet, I tried VGG and ResNet. They all seem to perform pretty well. So we'll just go with MobileNet for now. And I'll increase the model a little bit. Just adding another layer of dense. And this is just an attempt to make it a little bit more capable of handling the images. And then we can train it and we'll see what will happen. I think we need to train it for 100 epochs. Let's go with 5. And we can see here, it starts training, it looks fine. But it's, I mean, it hasn't gone too many epochs yet, it's just 1 epoch, but it's still not doing as well as you might expect from a MobileNet. We can keep training. I tried running this one for 100 epochs just to see if it got any better at any point. But no, it will stay equally confused. And I think it's because the MobileNet contains a pre-processing in itself. So when we normalize it, we kind of double that pre-processing. It's not, the images are no longer the format it expects or has been trained on. So the embedding it outputs, or the rather the feature it extracts, which is the point of MobileNet, right? We have the MobileNet to extract features from this image. And then we take these extracted features and we train a new smaller network on them, which can learn the specifics. Someone asked if I can share the hardware I'm using to train a model. I'm running it on a RTX 3070 NVIDIA graphics card. So yeah, we extract the features and then we use these features on a smaller smaller model which we train from scratch. And that's the entire setup with the pre-trained models. But if the images coming in are not what the MobileNet expects, the features it outputs are not going to be very helpful. And this entire part is just wasted. So what we're going to do instead is to go back and create a new model where we'll not use normalize. I'm putting them to 100 by 100. You don't really need to put them to 100 by 100. It's yeah, it'll probably work well even if you just go automatic, but it went a little bit slower for me before, especially when normalizing, so that's why I reduced it. So just to keep everything the same, we'll go with 100 by 100 here as well. We can already see it goes much faster to pre-process. Do it like that. 28 and Relo. And we should have the same model. Let's see how this one performs. I realized also that it might be good to have pooling on this one. We can try with that one after this and see what happens. I'll train this one for 5 epochs as well. And this one instantly looks better. It's not perfect yet, but we can see now that it's misclassifying a lot less than it did before. Which is also reflected in the accuracy, of course, where we no longer are at 20% accuracy I was before, but instead at 80% accuracy almost straight away. Okay. So yeah, here we can see we ended at 97% training accuracy and 80% validation, which is pretty good. And if we, especially compared to this one, which ended at 28, and if we evaluate this one, which is taking a surprisingly long time. This is something we're going to look at speeding up at some point. There we go. So here we have the test results. And as we can see, we have a nice diagonal here, where it's classifying most of the classes pretty well. It's we're confusing Frostmog sometimes with Sandstorm, in both ways actually. But the rest of them seem pretty good. With only small improvements here and there, which we probably can fix by training it longer. Or if we want to add in things like dropout, or again with the average polling. So that's one of the lessons for today. If you're using normalize and things are running poorly, double check if you're using a pre-trained component as well, because that might be why. But let's try. We can try running it on another one. MobileNet we saw was working pretty well. Can also try out ResNet and see how that one's working. This time I am going to pull it. Well, we can't average pull it. And let's see if we can activate a little bit of dropout to make the our training accuracy kept going up, but our validation accuracy did not. Dropout is a pretty good way to regularize it, to make hopefully the validation follow the training. Actually 0.27. There we go. So I make the dropout probability 25%, meaning that we 75% chance to keep it. I'll put it in both of these layers. can try, actually let's run it equally long, otherwise it will take a while. Did not like that. Okay, there we go. Looks like it was colliding with the previous results. So now with the dropout, we're having the accuracy start a little bit lower, but the goal is that we end up with a higher end accuracy. We're jumping a little bit back and forth in progress. Again, we're running development branch. And I'm guessing one of the newer changes is mixing up between the previous results and the new results. The training itself should be running just fine in the background though. So I'll just ignore it until we complete the training and we can look closer at the progress by then. Also look at the gradients. So looking fine, we start pretty high and then we go down. And if we want to look closer at if we are overfitting, we can look at the global loss. And we can easier zoom in here on the difference between the, there we go, difference between the validation and the training loss. And we can see here that they're starting to diverge at some point. It seems like we didn't get this end results from that one, but let's run it through evaluation. The previous categorical accuracy was 0.78, so let's see how this one's doing. One more thing I forgot to mention with the dataset. The images were a mix of RGB and grayscale, as far as I could see. And some images looked almost corrupt. They couldn't be loaded in when I was trying to load them and convert all to RGB. So if you're trying out the dataset, keep that in mind. We're also going to make the dataset available through our public dataset view. So you can easier download the exact same version which I have here, which is cleaned and in RGB. Well, we should soon get a pre-processing option of it out there where it automatically converts it to either RGB or grayscale. So you don't need to do that manually. And I didn't want to open that one. We can see that we have a little bit better categorical accuracy. It could be the dropout. It could also just be that we got a better initialization during this run than we did the last one. We can see top 5 is really high, meaning that within the result is almost one of the top 5 most likely. Or the top 5 which the model thinks is highest probability of being the correct one. And yeah, we can dig into the confusion matrix to better understand which ones are misclassifying. This is kind of what you want to do if you have a really sensitive case or if you want to optimize it for production. But in this case, I'm just very happy that we're finding mostly snow. So we'll probably leave it with that rather than dig into specific ones. And yeah, that's the entire snow model, or weather model rather. And what to watch out for when building it and what works well. We, as one final thing, I'll just build it with the larger images as well. And we can see if it performs better when it uses the entire image, or if it's better when it's just a small one. I use the same mobile net that we did before, and throw in a dense, just keeping everything the same. I could just copy paste the model from over there, but this works. And then we'll run it. So this should be without normalizing and just a larger image, which probably means that it will take a bit longer to train for one, but it might also take longer for the model to converge into a good value, or converge to a good solution. So you might have to train more epochs. It does look like it performs very well already though. We might not see too much difference between this one and 100, which is great. That means that you can use just 100 by 100 and you get away with faster training and a smaller model. Can maximize this one if we just want to look at how each class is being predicted as well. Seems like Rime and Glaze are the two, also Fog, what's that? Fogsmog are the most confusing ones for it so far, with Snow being a close second or fourth. At this point it is very accurate, just looking at this, and the training accuracy for sure is better than it was before. I believe the validation is as well. Let's actually stop it already, and we'll stop it and we'll run it through the test view. So you don't need to finish the entire training. That might also cause overfitting if we train it for too long. So the first one was 0.78, the second one was 0.80 something, 81, low 80s. We can see what categorical this one runs at. making a mental note to make sure that we do speed this one up. Or at the very least that we show something more interesting. I do believe you are able to go back to your model while this one is running though, and then as soon as it's done you can just go back and view it, but we don't have much else to do in the modeling right now. There we go. It is not good at all. Alright. That's interesting. It was performing really well in the training and validation, but in the test it seems... Oh, you can see for yourself it's confusing everything. And we have 0.1 categorical accuracy, which I'm guessing is about the same as if it's random. Okay, good to know. It could have been by... I'm thinking if it is because how I stopped it. Maybe it would have been fine if I let it finish training. We'll have to experiment on that. Anyway, that was everything I wanted to show for today. So thank you all very much for stopping by. Hope you enjoyed the snow model and the quick tidbit on normalizing. And I hope you all have a fantastic day, and if you can have snow, hope you're getting snow soon. Take care, everyone.